this video, we are going to discuss about the project title Predicting the Risk of Developing Diabetes Retinopathy Using Deep Learning. Globally, diabetic retinopathy is the leading cause of preventable blindness in adults aged 20 to 74 years. With the goal of early detection, regular screening is recommended by major organizations at intervals ranging from every 12 months to 24 months for patients with no or mild diabetic retinopathy. Although regular screening is crucial to preventing blindness, the expected increase in the number of patients with diabetes from 415 million in 2015 to predicted 614 million in 2040 means that the burden of screening and follow-up represents a subsistent challenge. The efficiency of diabetic retinopathy screening programs might be improved by the personalizing screening frequencies on the basis of livelihood of the development or progression of diabetic retinopathy. We created a deep learning system that uses color fundus photographs to predict the risk of the developing diabetic retinopathy. The main objective of this project is to predict the retina fundus color images, thus they consist of diabetic retinopathy or not. And with the algorithms inspection, V3 algorithm and IPAX algorithm. Hardware requirements: we need operating system Windows only, processor i5 and above, RAM should be 4 GB and above, hard disk 20 GB and above. Coming to the software requirements, we need to install Python with a version of 3.7. Methodologies: to implement this project, we have designed few modules. First one, upload diabetes retinopathy dataset. Using this module, we will upload dataset training images. Then second module, pre-processing images. Using this module, we will read all the images and then normalize images by converting all pixels values between 0 and 1. Dividing each pixel values by 258 will convert image pixel between 0 and 1. Next module, train diabetes images using deep learning model. Using this module, we will train the images with inspection V3 algorithm. Then next module, upload, test and image and predict diseases. After training the model, we will upload the new test images and then inspection model will predict what upcoming disease which has the test images to the dataset. Then next module, accuracy and loss graph. Using this module, we will plot the graphical representation of accuracy of the deep learning algorithms. Now coming to the execution, close this file and go to the code file. This is the code file, consists of dataset files and these are the global images, and these are the model files which consist of .h5 files, pickle files and .npy files. A pickle file is a serialized data format in Python used for object serialization. It allows to save the Python objects in a file and later load them back into the memory. And coming to the .h5 files, contains algorithm information and can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Next one, .npy format. It is the standard of binary file format in NumPy for persisting a single arbitrary NumPy array on disk. The format stores all of the shapes and data types informations necessary to reconstruct the array correctly, even on another machine with a different architecture. Then coming to these text files, these are the test files used to detect that algorithm is predicting or correctly or not, and these are the code files and this is the runbat file. This runbat file, instead of executing the program in command line interface, we created Windows bat file to execute the program. Now clicking double tab on it, it leads to the user graphical interface which is interactive to the program user. And here the first button is upload diabetic retinopathy dataset. By clicking this button, you can see the dialog box open and select the diabetic retinopathy dataset and select it. Now you can see that dataset is completely loaded. Now next button, click on the pre-processing images. By clicking this button, you can see that the text of the images which we are having that are normalized, read and extracted the features. Now this is the sample loaded images shown here. Now close this one and go to the next button, that is train diabetes image using deep learning model. So by clicking this image, the deep learning model will be generated in the back console with the dimensions, output, shape, and here you can see the graphical representation of the deep learning algorithm which was predicted in the false positive rate and true positive rate. Close this graphical representation and you can see on the graphical user interface, that is retinopathy diabetes training model prediction, that is deep learning model prediction accuracy. Then next one, load Gabber features. This simplest way to generate features with Gabber filter is to use the real or imaginary part of the responses matrix as a feature vector. Now the face of the response matrix can be taken as the feature vector since it contains relevant information about the edges. So this Gabber filter will be generated the main features and also it takes the sample features extracted and take the all the outlines from them. So now close this one and go to the next button, that is train diabetes with the deep learning and Gabber features. So now we are going to combine the Gabber optimization features and also deep learning algorithm by predicting the accuracy. So in the back console, it will generate the model generates deep learning model generates the Gabber features optimization model output and it will show the optimization retinopathy dataset model training prediction accuracy in the graphical user interface. The next button, click on upload test image and predict disease. By clicking this button, you can see the number of images found in different classes. Now select the image and click on open button. So it will generate the image consists of any retinopathy diseases found is may get disease in 2 years predicted. So this retinopathy fundus color retina consists of the disease is predicted, maybe it occurs the disease in upcoming 2 years. Now close this file and text with the another image. So now you can see that it is also predicted with the next 2 years. So now you can see the graphical representation by clicking the accuracy and comparison graph button. So here you can see the normal CNN loss and also normal CNN accuracy and Gabber CNN loss and Gabber CNN accuracy. Here you can see the green line and the red line indicates the Gabber CNN loss and accuracy and blue line and yellow line indicates the normal CNN loss and accuracy. So here the accuracy will be increased by the approaches increases, but coming to the loss will be decreases when the approaches increases. You can see here, calculate that red line indicates that Gabber CNN accuracy and yellow line indicates that normal CNN accuracy. See the differentiation. So after Gabber optimization, CNN volume of accuracy was increased and also decrease in the loss graph. So in the x-axis it are the number of the approaches and in the y-axis there are the number of the frequency levels of accuracy and loss. Close this graphical representation and click on the next button, that is CNN confusion matrix graph. Now you can see the graphical representation of CNN confusion matrix with the predicted class that did not know and known values of the outputs and true classes. Now close this one and go to the next button, that is Gabber confusion matrix graph. By clicking this confusion matrix graphical representation button, you can see the graphical representation of Gabber optimization CNN confusion matrix with the predicted classes and true classes. Now in such a way we are going to find out that if the retina consists of the fundus consists of any type of diseases in advance. Now close this code and exit the complete file and go to conclusion. In this project, we are going to find that we have found that by using Gabor optimization with the CNN algorithm has predicted with the best accuracy, and also the Gabor CNN algorithm is predicting with the diabetes retinopathy in advance. It can lead into the reduction of many diseases and also prevent in advance to under the cure, and it will neglect so many problems to blindness.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.